Okay, welcome everyone. I hope you all had a good coffee now, so you're wide awake. This will be a whirlwind tour of JDK tools, so I might or might not quiz you at the end, so please pay attention. But you don't need to write it all down. I have a barcode at the end, and it's a lot of stuff. And what I mostly want to do is give you an overview of what's there, so that when you come into a situation where some of these tools could be useful to you, you kind of remember that these are there, and then you can go back and look them up and get familiar. Some of them, actually, I want you to start using right now, so today, from today, because they're so useful that you shouldn't live without them. My name is Michael. I've been working with Neo4j for 13 years now, really long time. I'm doing DevRel and innovation and modern technology integrations. You could tell it from all the stickers on the laptop. And I'm really deep into open source, so I even carry the open source t-shirt so to demonstrate that. If you look at the JDK, there are so many tools, right? So if you just ls into the bin directory of your Java home, it's kind of this endless list of binaries. And who's ever done that and looked at the list of binaries that are sitting there? So 30%? Good. So, and some of them we'll look at, and some of them that we look at will actually not be in this list, but they're so good that I need to talk about them anyway. Okay, let's get started. SDKMAN. SDKMAN is awesome because SDKMAN manages all the nitty-gritty detail of installing and managing not just JDKs, but all kinds of other tools for you. And I'll try to keep this interactive, so I switch back and forth between the terminal and the slides. Can you read this in the end, or should I make it bigger? It's good? Cool. So SDKMAN, you just install it with curl SDK, and then you have it installed. It adds to your profile, so it's available in your shell. And then you can say, for instance, SDK list, and it shows you all the stuff that you can install with JDKMAN. So you can do ASCII Doctor, Maven, Java, GraalVM, Spring Boot, Flink, Spark, Groovy, you name it, Micronaut, and so on, right? So you can install all and manage all kinds of stuff. It gives you updates when there are new versions available. So it's really easy to manage a lot of tools on your machine at once. And if you want to look at Java, we just say SDK list Java, and then we get all the JDKs that are available. And so fortunately, now we live in a time of like plenty, right? So there's like plenty of vendors for JDKs. Even Microsoft now has their own JDK, AWS has their own JDK. We have GraalVM, Java.NET, Liberica, SAP, Oracle JDK, and so on. So there's a wide choice depending on what you can use, what you need to use based on license and so on. And it's basically as easy as saying SDK install Java, and then the version that you want to install, and then downloads it, pre-packages it for your system. And actually, something I forgot to mention is, on top it says available Java versions for ARM 64-bit macOS. So you can actually configure SDKMAN to only pull the JDKs that are relevant for your platform. So if you're running on an ARM or an M1 or M2 computer, then it only pulls the JDKs that are optimized for the ARM builds, which is nowadays quite important. So I already downloaded it because I didn't want to bore you waiting 5 minutes on the conference Wi-Fi for downloading it. But now I can actually basically just say SDK use Java 20 open, and then Java dash version shows you this is Java 20. Unfortunately, because I'm German, all the JDK tools decide to pick up the German help text and languages and outputs, which is super annoying and super horrifying if you read them. So that's why you can set actually in Java tool options a language, but then every Java tool also says, oh, I'm picking up options from Java tool options, so which is also not so helpful, but at least it's not German anymore. What you can also do is use EAP versions. So in the list, you might have seen there's Java 21 even in there, so I can also just say, I want to use an early access of Java 21, and then basically start using that with the new features, right? So you don't need to wait until September to start testing out a new Java things in Java 21. You can just do it today. And there's like new versions coming out every 2 to 4 weeks, actually. So let's go back to Java 20. And so SDKMAN is still my first tool in the list. That's super useful. Right? So Java 20 was released in March. The next one is in September, so I can't wait for Java 21 as an LTS. Java execution. So in the old days, we always had to take a Java source file, compile it with Java-C, and then or with Maven or Ant or Gradle, and then basically execute it afterwards. But for a while, we've been having the availability of actually executing things directly with Java and also with JShell. So let's start with JShell. So JShell is a REPL for Java that has been around since Java 9. In the early days, it was a bit verbose because you had to declare types and stuff like that, which got much easier with Java 11, where you can just do var and provide real names. You can also provide to JShell class paths or module paths. So if you have external libraries that you want to use, you can provide these as well. And it can do a lot of stuff. It can compute expressions. You can define classes, methods, do lambdas, and so on. So if you try this, we can basically just run JShell enable preview, and then it basically opens JShell. We can just run computation and expressions. For instance, printing out stuff. We can test out streams. And you see that some Java util packages are automatically imported, so you don't need to spell out basically Java util stream or Java util or Java lang things. And as you saw, I started it with enable preview. So that means we can also test virtual threads, for instance, right? So I can basically just open a bunch of virtual threads, run them, and you see here also that they're basically virtual threads are running on the worker threads. So you have much fewer worker threads than you have virtual threads. So if I increase this to, let's say, 100 or something like that, then you will see that there are much fewer worker threads. There's only like 10 worker threads for 100 virtual threads that are running, right? So I can also use JShell really quickly to test out things. I can also say I have an record conference with string name and string location or something like that, and int here. And then it creates a record, and I can start using records as well, right? So all the new features are really easy to use in JShell, and you can even do complex stuff. So here, for instance, I wrote a small game of life that just generates 10 generation of cells, and so you basically can also do more complex codes with classes and methods and so on, right? So quite nice. Okay, Java execution. So in Java 11, Java itself got the additional availability to actually run Java source code directly, so you don't need to compile it first, but you can run it directly. And so you basically can take anything that's a Java source code file and run this, and then you can again provide class paths and similar. And if you go back to our shell, you can just create this Java file, and then basically just run it with Java hello.java. It says hello, and if we say London, it says hello London, right? What we can also do, we can turn this actually into an executable. So if we, for instance, you can copy this to an hello, change the executable flag, and add an JBang at the top, so that the shell knows what to do with it. So it's basically user bin Java source 20, and then we can basically just execute hello devox, and it basically runs it as an executable, which is really nice for small scripting things as such, right? But imagine you don't just want to use the built-in Java JDK classes, but other things. It becomes tedious because then you have to provide class paths and download the jars somewhere or get your Gradle or Maven repository kind of super long URLs in there, and it gets kind of tedious. So it's nice for small things, quick stuff, but for real, I wouldn't do this. We have a much better tool for that. Something else, talking about Java, there are like hundreds of Java flags for the JVM. I never remember correct ones or the correct syntax. So there are some really nice online tools. Like for instance from Chris Newlands, there's a VM Options Explorer. I can really recommend that. If you look for certain options, please check that out. For every version, you can also see the differences between versions, what was added in new versions, and so on. Okay, now the real tool for executing Java code is actually JBang, right? Max Anderson created this amazing tool where he said actually he wanted to make JavaScripting as easy as Python, right? Which I think is good, right? So there's no need for POM XMLs or build Gradle files. You don't need to have this Java setup with the whole thing. Just a Java file with a bunch of comments on top. If you've used Groovy before and have used the grep annotations, so that's where I think some of the inspiration came from, where you could basically just specify, oh, these are my dependencies on top of a Groovy file, and basically Groovy downloaded the dependencies with Ivy, I think back then, and made them available. And with JBang, it's as easy. Right? It can run local files, it can run files from URL. So if someone else wrote a file in your company or something that you like, it asks you before if you trust this file and URL to execute it. But then it's just running it. But Max didn't stop there, right? So he didn't say, okay, that's good enough. He added stuff like, okay, if you want to edit Java source files in your IDE, then you still need all the boilerplate Maven Gradle setup around it, right? So what he did is basically he added also code that when you want to edit something, you just say JBang edit file, and then it basically temporarily generates a Java project that has your file in there. And so all the type completion and library dependencies, everything works. And when you save it, it's still your file left, and the temporary project is gone. So you don't have all the other stuff around, right? Which is really cool. And then he went even further with a catalog and a template library, and you can say, basically, I want to generate a CLI application or a controller or something else. So it's pretty cool. So if you want to test this, we can do it directly on the command line. We can say, so we can also install JBang and maintain JBang with SDKMAN, of course, so it's kind of circular, right? So I basically just can say JBang init -t-CLI says I want to have a Pico CLI app, right? So it just has these kind of templates that it fills in, and then we have our hello CLI.java, and it already exists, so I can just remove the old one. And then if I look at this file, it's basically, you see the comments on top, which is the JBang end variable, and then dependency is Pico CLI, right? And then if you have more dependencies, you just add your other dependencies on top of that, right? The imports are there from the template, and then it just has the code for doing the hello world. So if I do JBang run hello CLI, then it says hello world, and if I say hello London, then it takes hello London from the command line parameter. Right? And it basically builds the jar and then executes the jar behind the scenes with dependencies and all the other things. But in my folder, I have just the file, right? So there's no stuff here, right? So it's basically just the file. So even in the whole folder, I don't have any other POM files or so. But if I do JBang edit hello CLI.java, it opens your editor, so I have just set it to use Fleet from JetBrains for the time being. And it actually, why is it not showing the right thing? So it basically, you have the file here, and for instance, if I now change this hello to yo, save the file and run this again, here, should say yo London, right? And if I close this and actually you see, I'm not sure why it's not updating the location here. I probably don't go to check it. But it's basically just generated in your temp directory with all the POM and Gradle. So I think POM or build.gradle, Gradle, build. but that's the wrong one. But it just generates it, and when you close your editor, it's basically gone, right? Which is really nice. You can also do a lot of advanced options in JBang as well. So what I did also for today is I created this neotest file, which basically uses Neo4j Java driver, uses Java 20 with enable preview, so you can basically provide on top these options, and then JBang will adhere to these options as well. And then you can do much more complex stuff in here as well, right? And we're going to use this file later to performance test some Neo4j stuff. And I thought, why don't I just write this with JBang, because that's much easier, right? Okay, next one, JWeb server. Who of you has in the past used Python -m HTTP, a simple HTTP server or HTTP server to serve local files on the directory? So some of you, Java can do this now as well. So JWeb server is in there since Java 18. The underlying HTTP server infrastructure has been around, I think, since Java 14 or something like that. But it allows you to quickly serve a local folder as an HTTP folder, and which is really nice because sometimes you just need to expose or try out an index HTML without doing things. And what you can basically do here is you just say JWeb server and specify the folder, and then if I run this, it opens up the folder on localhost 8000. And then here you can see it's basically my bunch of Java files that I just generated here. Right? So that's really nice if you have some JavaScript or other code that you want to serve quickly. So that's something that's definitely useful. And the underlying HTTP server infrastructure is also really nice because you can easily now build small HTTP servers in Java without any external dependencies as well. Right? Okay, that was a quick one. Monitoring operations, right? So if you run Java stuff, so Neo4j has 4j in its name, so you know that's built in Java, right? So at least in the 2000s, that was really hip. Nowadays, we get questions, are you log4j or something like that? So, you know. But of course, you have running Java processes either on your own machine or on a server. So you want to interact and deal with them for monitoring, for debugging, for profiling, and other things, right? So the quickest thing is, I'm not sure who of you has done this ps aux ww grep Java before. That's kind of what I've done in the old days. And then it shows you like all the Java processes, and then you have to pick out which one is the right one, and so on. What you can do today is actually use GPS, and GPS is basically just in Java PS. It just shows you the Java processes, and then you can basically provide a number of command line options, like I want to just see the pits, or I want to have the full class name, or I want to have the command line options, which is, I think, -m. Then you get the full command line options as well. There's also one where you can get the class path as well, right? So that's an easy way of grabbing the Java processes on your machine and then dealing with them and their pits. Okay, next one is JStack. So we all know that Java runs a lot of threads. With virtual threads, it will even get more, right? So we have, plethora of threads to deal with. And of course, if something doesn't work well or something gets stuck, you want to know where is it stuck, right? And usually in your IDE or debugger, you can basically get a thread dump or kind of pause your debugger and hold it and look at the individual threads as such. But if your application is running on a remote machine or on a machine, then it's not so easy when you just have a shell or terminal. So in the old days, actually, since the first version of Java, you could just send a signal to it with kill -3. So if I do kill -3, so I use just the Neo4j. Where's it? Neo4j server, kill -3. This one. So nothing happens, right? Why doesn't anything happen? Because the Java process dumps the thread dump to its standard out or standard error. I forgot. I think it might be a standard error. So I basically need to go to my server, and then in standard out, I find the thread dump, which is not so helpful, right? So because then you have to extract it from the log file, which kind of sucks. And that's why with JStack, we can basically just get this thread dump here, and then can use that, pipe it into file or into pb copy. So if I've never used pb copy or pb paste on a Mac, it's super helpful because it basically takes whatever comes into a standard in, puts it into the clipboard, and then I can basically just open a new file here and then paste it in. The same, you can also do pb paste. Pb paste. So whatever is in the clipboard, I can push it through a command. For instance, if I push it through sort and then do pb copy again, pb copy. So I just go to the Unix shell for a temporary thing, and then it basically, now I get a completely useless sorted output of my thread dump, right? But you can imagine there are more useful uses of this. So just as a quick aside, which is actually not related to Java or Java tools, but it's super helpful. And there's a similar, I think it's Xclip on Linux as well, if I'm not mistaken. Okay, really nice. What's also really cool, you can do a forced thread dump. So if you do JStack -f, it will also force a thread dump, even if the JVM is stuck. You have the chance to still get a thread dump, which can be really useful as such. And then it has also options to give you more detail on deadlocks and monitors and other things as well. So you get even more detail as such, right? So that's really good for getting quickly something in there. But lo and behold, there's even a more powerful tool there. So JCMD is like the Swiss Army knife. I should have probably used the Swiss Army knife representation here. Is there actually a Duke with a Swiss Army knife, Andres? Should probably create one, right? So JCMD is really like the Swiss Army knife of tools. So you can basically control your JVM remotely. So you can do anything from running garbage collection, starting JFR recordings. You can get heap information, statistics, and so on, which is really cool. And what's also cool is you don't actually need to use the PID. You can also just use your or the beginnings of your Java process name. So you don't need to figure out, okay, what's the PID of my process, and I need to basically change this. And but you can just use it like this. So if you want to try this out, we can just say JCMD and our PID initially, and basically that's the Neo4j process, and it basically tells us, oh, there's a lot of stuff that you can do, right? So you can do compiler things, do kind of codeless directives, GC histograms, GC run, JFR stop and start, management agent. You can get the classes that have been loaded by the VM info and so on. So which is quite a lot of stuff, right? So for instance, I can say GC run. So if I want to force a GC, basically, then on my Java process, I can just do a GC run. I can also do something like VM info, which gives me then virtual machine info, including class paths, flags, and system information as well, which is really interesting. And you can also pass multiple things. And that's actually a nice trick I learned a few years ago. If in a Unix command line you need to generate like \n's with actually typing them out, you can just use a dollar and then single quotes, and then every \n, \t, and so on within this single quote string is actually turned into the representation. Something really useful, especially if you use SED and other commands where you want to do multi-line stuff, then that's really useful. So I basically can pass 3 commands to a single JSMT invocation here at once. And it basically gives me VM version, VM uptime, and VM flags in one go, right? Which is quite useful. Okay. So there's much more, as I showed you with the help. So you can get thread information and other things. For instance, GC heap info. So if we do not VM info, but gc.heap info, I get like garbage collector information, kind of what's the size of my young and Eden space, what's the meta space, class space, and so on. And there's also more detail available there as well. So I won't go too deep into Java Flight Recorder or JDK Flight Recorder as such, but it's a super powerful monitoring and profiling tool that you can use which has actually low impact on the JVM, and it basically records JVM events. There's much more detail on that. Gunnar Morling has done amazing blog posts on JFR, so if you want to know more, check out Gunnar's blog. What I just want to say is you can basically record a lot of different events from method calls to allocations. You can even create your own JFR events that you then can record. So for instance, if you have application events that you want to mix and match or kind of interlock with JVM events, then you can do this as well. So it's really cool. I just want to show you that with JCMD, you can also basically start and stop JFR recordings and then basically use them. JFR can also output summaries, overviews, percentages, and things like that. You can filter by categories or by event types. So there's a lot of stuff in JFR, but it's too much and too deep to go really deep into it. But just know that it's there and that we can use it. And as an example, we can do a quick recording of something happening in Neo4j, and then we can get an overview as such. Right. OK, and to do this, we basically can start a test here for Neo4j. So we just run a few thousand requests. Let's say concurrency 6, and 10,000 might be too little. Let's run 20,000 requests for each thread. So while Neo4j is now busy doing stuff, we can basically say JCMD, or let me copy it out so that I don't mistype it. So you can basically say JCMD, your name and JFR start, give it a name. And then after a while, I want to do a JFR dump. So basically, whatever has been recorded in those seconds, which are now over, I want to dump this to a file. And then I can stop the recording with JFR stop. So I can, of course, script this really easily as such. And now I have in temp my JFR recording JFR. And so it's not too big because you only did like a few seconds, but it can grow depending on how much you collect. It can grow pretty quickly. And then JFR itself has a number of command line options that you can use. But of course, if you want to use the full power of JFR recordings, look at Java or JDK mission control to do more. But for instance, what I can do now is basically say, I have a JFR summary of my recordings file, and I just want to see the recordings and what are the events that have been collected. And you see there's like allocation events, class loader events, native library events, and so on. So you basically can then dive into, with all the JFR options, into analyzing those JFR files as such. And JCMD is basically an entry point to that, where you can easily get into remote controlling the JVM, even if it's not running on your own system, which is really nice. Right? OK, continuing with monitoring. Who of you has used Async Profiler or Flame Graphs or things like that? So 1, 2, 3, 4, 5, 6. So a few people. So first of all, Async Profiler is amazing and Flame Graphs are amazing. Right? So I need to say that. So Brendan Gregg did a really great job. I'll show you what the flame graphs look like. So first of all, it's beautiful, right? And you can always annoy your colleagues by sending around flame graphs because it will always point them to, oh, here's a bottleneck in our code and that we should fix. I'll talk a little bit more about the details, but it's just beautiful. And basically, they represent the number of call traces that happened. So it basically collects stack traces, and then it basically just accumulates how often did each line of the stack trace come up. So it's not a time-based measurement, it's more a count-based measurement. And you see kind of, compared to the overall runtime or overall invocation count, how often did a certain part of your application get through when you sample on it. And you see basically where is the most time spent, where time is implicit as such. But to get to flame graphs, either in the old days, you needed to use some low-level tools like Ktrace and others, strace on Linux. Brandon has also built a bunch of tools that do this. But for Java, I've now default to Async Profiler. Async Profiler is also integrated in IntelliJ. So if you want to don't want to deal with the command line options, which is actually super simple. You can also just basically profile your application from IntelliJ as well. I'm not sure if it's in Community Edition, but it's in Ultimate Edition definitely, but I'm not sure if it's also in Community. But it's a super cool feature. But you don't need it. You can just do it from command line. I don't want to go too deep into the whole profiler discussion, but you might know that profilers, when you start profiling your application, it also affects your application runtime, right? So because either profilers use sampling, which can only happen in save points. So it's basically whatever the profiler is skewed towards threads being in save points. So it's not the real thing that happens. Or your profiler instruments your code with bytecode manipulation within Java agent. But then, of course, the instrumentation affects the runtime of your program. So it might exhibit or not exhibit certain things that it did before. And it also impacts performance a lot. So it can be up to, I think, 20 to 30% in the end if you have heavy instrumentation from your profiler. So profilers, I mean, it's difficult to trust profilers. They can point you to some like suspects in your code, but you then should really, investigate and narrow down. And sometimes you have really weird things that are obviously not the cause of your problem, but they show up in the profiling a lot because it's in the save point, and that's why it pops up. And a while ago, someone, I don't remember actually who it was, discovered in the JVM there's a really interesting call, which is called async get call trace. It's like C-level call, and you can basically get a stack trace of all threads in your JVM without entering a save point. So even if the threads are not in a save point, it's basically just okay, give me what's currently the state, right? And this enabled a lot of kind of these low-level or these high-performance profilers because they are not affecting your Java program as it runs. They just get what's the current state as such. And it's much more a realistic image of what's happening in your JVM. And what's also nice, Async Profiler also has means to not just sample the JVM stuff, but also what happens in the kernel. So that means when you have certain calls that do, let's say, file I/O, network I/O, or locking or other things, where there's a lot of back and forth between the kernel and the JVM. You see this also in your async profile. And you also see GC and things like that, right? So which is also super helpful as such. And async profiler can sample call basically method calls, but it can also sample allocation. So if you have memory problems, you can also use it for sampling allocations as well. So, and actually to use it, it's super simple because you just download the last binary from GitHub, from the GitHub release, and it's available for Linux and for OS X, also for ARM now. And I don't think it's available for Windows, but so be it. So I basically have my async profiler here downloaded. 2.8.3 might not even be the latest version. And there's a profiler.sh shell script, which does all the heavy lifting. And the only thing that I need is basically my my PID, a duration. So I just want to sample for, let's say, we don't want to wait too long, 15 seconds. And then we output the thing to an HTML file. It used to be SVG, but now it generates as HTML. So it's, if you have certain browsers that don't do well with pure SVG files, it actually does it as such. So that's all that you need to know for the async profiler call, not too much magic, right? I mean, all the magic happens under the hood, of course, right? So this is kind of the nice user interface. So we can run our test again. So how long did that actually run? 14 seconds, so that's almost perfect. So while this is running, our Neo4j instance basically runs a lot of threads. So if you look at htop, it should show up that all my CPUs are busy here, right? For 14 seconds. So this is over. So I did like 4,000 requests, 8,000 requests per second. Profiling is also done. And now we can basically open in Arc our flame graph. By the way, if anyone wants an Arc invite code and hasn't got one, come to me after the talk and I can give you one. And then this is basically the flame graph of the application that we just profiled, right? So, and what we can do here, I'll make it a little bit bigger. You see, this is the overall baseline stack root, basically. And then all the green stuff is in the JVM. The yellow and reddish stuff is in the kernel. And then you can basically look at, oh, what's actually happening here? Oh, there's a lot of stuff where monitor wait is happening in some channel promises. And this is something in Netty where basically the client waits for the database to deliver records basically as such, right? So, but I can drill down and say, oh, this is actually unexpected. It shouldn't spend so much time here waiting for something. So what's the root cause? You also see all threads at the same time. So it's not like one thread, but it's kind of all threads. So you also see what the whole application is actually doing, right? So there's a lot of waiting happening, as you can see. So we could dive into what are these threads waiting for and what is busy. And then you see also like these very deep call traces here. I think this is all the Scala stuff of the query execution engine as such. You can click on any of these and then it takes this level as the new root and you see more detail on top, right? So now I see basically this is here still driver, reactor, query runtime. And this is actually logging. See, so we found something where it actually logs stuff, which should actually not have so much impact. So if we kind of modify logging settings, we could basically get a few % perhaps of performance out of our server. So it's already a nice finding that I can take back to my colleagues as such. Nice. Or I just move it from info logging to error of one logging, and then perhaps even it works. Right. Cool. So we even learned something about our Neo4j instance. By the way, really quick thing, if you ever want to deal with connected data, then you can do fun stuff like this. So this is like a million users with 10 million connections in a graph that these queries were running on that I just generated a few minutes ago. So if you want to know more about the Neo stuff, find me also later. Exactly, we talked about Flamegraphs already. Beautiful Flamegraphs. And they've been so useful to us in performance testing, finding bottlenecks, and so on. I really recommend if you have performance critical applications, there's no way around Async Profiler and Flamegraphs, right? So it's really should be part of your tooling as such. Cool, we have some time left, so we can go into the bonus section actually, which will make Andres happy. So we look at JLink. So JLink was interesting. I wasn't aware of JLink for quite some time because I kind of stayed away from the whole module system thing, which kind of still scares me. I think I'm probably OSGI burned from back then, and ever since I've been not, getting too close to module systems. But JLink has some really other cool features which I want to show you. So JLink allows you to build custom JDKs. Who of you has built custom JDKs so far? 1, 2, 3. 4 people? Good. So it's actually fun, right? Did you know that? I didn't know before that I can build my custom JDK. Pretty cool. So since Java 9, since the module stuff started in Java, basically the JDK has been partitioned in a number of modules. Oh, sorry, I forgot the S at the end. Sorry. So, and now the whole, what used to be just rt.jar is like all modules basically, right? So you have stuff for HEP, for logging, for Java base, which is kind of the base JDK. You have Koba is probably, I don't know actually if Koba is still in there. You have JSON, XML, and crypto and all this stuff is individual modules. That means when the application runs, only the modules are actually loaded that are needed and not the whole rt.jar, which is already helpful. But of course, it would be nicer if I know that my application, for instance, I have a microservice that just basically takes some data, converts it, and spits it out back again. It doesn't need all these millions of modules, right? So, so you could either go the native route with GraalVM, a native image, but you can also build your own JDK, which can be smaller, right? So if you look at the size of our JDK, so in our SDKMAN folder, let's see, we have candidates, and in candidates Java, you have all the JDKs that we have downloaded. And if you look at Java 20, it's 320 megabytes, right? Not bad. But can we make it smaller, right? So for instance, if we really want to have just a minimal JDK that has just the Java base module, then we can do this, right? So then we can Okay, it's not there. So we can just use JLink and say the only module that we want to add is Java base, right? And we want to output this to a JDK base, which I thought I had removed. Oops, sorry. It complains if the thing is already there. So we just do this, and it takes a few seconds, and then we see our JDK base is now 43 megabytes. Nice, right? And if I do a JDK base bin Java list modules, there's only one module left, right? We used to have, let's see, 70 modules in our JDK or JVM, and now we have one left, right? And the size got much smaller. You can also do compress on this, so it even compresses it more. Let's see what comes out of this. Compress. And 29 megabytes, right? That's a 10x smaller module. And if I don't need anything outside of Java base, then I save quite a lot of space in my JDK, right? And then, of course, you can do, if you go fully into the module thing, then you basically can also say, I want to say, I have built my application on modules, so I can also look at my jar or my modules and see which jars are actually used here. That's a tool, it's called JDeps, it's a kind of dependencies. So I have a really basic jar here which just uses a Java base. So it says JDeps just uses Java base, so I can basically build a JDK which just has Java base. And if I have something else, like here I have something that's an HEP module, and it says I need Java base, Java logging, and Java net HEP, and then I can build a JDK that has only these modules in there, right? And you don't need to use jars, you can also use, as you can see here, module paths as well, right? Cool. And we're almost at the end. The last one is deprecation. Now that the JDK pace has picked up for a few years, and we get a new release every 6 months, and the LTS release cadence has also increased or decreased. No, the cadence has increased, right? It's important to keep up to date. Am I using deprecated features? We might actually now be removed in a few versions, right? And that's JDeprecation scan, and which is also super simple to use. You point it at your jar files. So here I just pulled Neo4j kernel jar. And I want to see for Java 20 what kind of deprecated features is it using. I just pulled it from Maven Central basically, and basically says it uses thread get ID and a URL init with a string, and these are deprecated features, so they might be removed in one of the next Java releases, right? So if you try this with your jars, it's probably interesting to see what's in there. We used to use a lot of unsafe, so which we already had to remove for memory management and stuff. But that's something that's really useful to not be surprised by things that are happening. Cool, and with this, we actually made it through, and you learned a lot. I hope, at least. So that's the quiz, actually. Who learned something that I didn't know before today? Super. I think I made what I wanted to do. I put all the invocations into a GitHub gist, so that's the first link there. The barcode should get you to the presentation, so you have all the slides there, plus the links to the resources. So in general, there's a lot of cool stuff on the command line, and I really encourage you to use it. Don't be afraid of the command line. Command line is your friend. Now you have in all the IDEs integrated terminals, which then integrate with the IDE as well, so even better. So we have 7 minutes for questions. If you have any, please go ahead.
Questions? That will be a hard one.
With creating a custom JDK, is the benefit mostly on memory, or does it actually lead to a decent amount of performance improvement as well if you cut it right down?
So I think it's mostly, so the question was, for building custom JDKs, is it mostly about memory, or does it also improve performance as such? So I think it's the size improvement. So for instance, if you build containers and so, then the smaller size helps you. In terms of memory, I think with the modularization of the JDK, it only loads the modules anyway that are needed by your application. So from that perspective, it might not save too much on that side. It's more like the size and the customization. What I forgot to say is, in your custom JDKs, you can also package your own modules into the JDK. So imagine you have a number of modules in your company that you're using all the time anyway. So you build custom JDKs for your company, so that your jar that you actually need to run your application for doesn't need to have all these dependencies as an Uber jar. So you just have your application jar, and all the dependencies are actually already in your custom JDK or JVM. So you don't need to ship all these dependencies time and again. And with compress, it even gets smaller. So that's another advantage that I forgot to mention. But thank you for the question. Any other questions? I know it's lunchtime as well, and you need to go, but if not, try it out. Let me know. Share on Mastodon or Blue Sky or Twitter what you learned, and share the things with your colleagues at home. I hope this was useful, and thank you all.